The poles may soon switch. Earth's poles could switch, but we don't know when. Earth's magnetic poles switch every few 100,000 years or so, and we apparently are overdue for another flip soon. Earth's rotation around its planetary core generates a magnetic field around the planet. This field creates two magnetic poles. Unlike the geographical south and north poles, which remain affixed, the magnetic poles are constantly shifting. Writing in the publication Conversation, scientists from the University of Leeds say a reversal of the poles could happen in the next 2,000 years. They warn such events are difficult to predict, but speculate such an event could lead to multiple poles and a weakened magnetic field. This could allow more radiation to pass through onto the planet, and could also impact the planet's electrical and electronic infrastructure. More on planet Earth. The UN says the Pacific Ring of Fire is active. The Pacific has been rife with volcanic and seismic activity this week. After recent eruptions and earthquakes in the Philippines, Indonesia, Japan, and Alaska, the United Nations has warned the Ring of Fire is active. As the naming implies, it is a ring of hundreds of volcanoes spanning 25,000 miles across the Pacific Ocean. Much of it was created through the subduction of tectonic plates. This is where oceanic crust of the Earth clashes with heavier continental plates and is forced underneath them due to the weight. The resulting pressure is explosive and results in magma eruptions and earthquakes. Because of these subduction zones, the Ring of Fire is home to 452 volcanoes and around 90% of the world's earthquakes.
Solar flare! The glowing yellow orb of life, floating millions of miles away at the center of our solar system, flared up in a massive way this week. A massive storm over the sun on Wednesday discharged the strongest solar flare in 10 years. The National Oceanic and Atmospheric Administration says the X9.3 flare caused high-frequency radio blackouts and navigational issues over the sunlit part of Earth. According to NASA, solar flares take place when magnetic energy built up within the sun's atmosphere is suddenly released. They impact everything on the electromagnetic spectrum, from radio waves to X-rays. The energy released is equivalent to millions of 100 megaton nuclear bombs exploding at the same time. The last solar flare of similar strength occurred in 2006, and the strongest on record took place in 2001. The Earth has its own way of cooling rising temperatures. Scientists have long speculated the Earth has a natural thermostat that regulates global temperatures by increasing or decreasing the amount of carbon dioxide in the atmosphere. Now, a new study suggests this could be true. Researchers have found a correlation between greater deposits of lithium in limestone rocks and warmer periods in the planet's history, when the Earth's weathering thermostat sped up. Carbon dioxide traps heat in the Earth's atmosphere. A dip in carbon dioxide levels can potentially cause an ice age, while a spike can make the planet heat up. The Earth regulates carbon dioxide through a process called the weathering thermostat. Carbon dioxide is removed from the atmosphere when it dissolves in rainwater and combines with rocks to form bicarbonate. When rocks dissolve in water, the bicarbonate combines with calcium to form limestone, locking carbon dioxide inside. Movement of tectonic plates then draws the limestone under the Earth's crust. The carbon dioxide eventually returns to the atmosphere when it separates from the limestone and is thrust out in volcanic eruptions. According to researchers, the Earth's thermostat responds to changes in the planet's temperature. Heat speeds up the weathering process, while cold slows it down. Other influences on the climate include solar activity, the growth of vegetation, and the impact of human activity. Scientists believe the Earth's natural thermostat cannot keep up with man-made climate change, and are now looking into ways to artificially speed up the weathering process to counter global warming. Cooling the planet at a cost. As temperatures on Earth reach unprecedented highs, extreme, potentially disastrous weather will become more likely. Scientists say there may be ways to intervene, but warn they come with risky consequences. Researchers are investigating strategies for geoengineering, one of which is mimicking the effects of a volcanic eruption. Erupting volcanoes spew out large amounts of sulfur-rich gases, which help cool the Earth by reflecting solar radiation back into space. The same effect could be recreated using planes that would inject sulfur into the atmosphere. But to cool the planet by 1 degree Celsius, 6,700 injections are needed eventually, which would cost $20 billion annually. This approach also risks destroying the ozone layer and reducing rainfall, enough to potentially cause droughts in certain regions. A similarly drastic approach to cooling the Earth can be achieved by thinning heat-trapping cirrus clouds. Seeding causes the clouds to break apart and lets more heat escape. The seeding process, however, must be precise, otherwise new cirrus clouds may form elsewhere and add to warming. But while sulfur injections and cirrus cloud seedings will cool the land, carbon dioxide levels in the atmosphere remain the same, and ocean acidification continues. As such, researchers argue the two strategies should be deployed more as a last resort, adding that reducing carbon emissions are much more effective at curing climate change.